Thanks for coming out to this talk. My name is Jearvon. We're going to be talking about a little bit about security today. So quick survey. How many people run their stuff in the public cloud? And how many people run that in AWS? Well, AWS is making money. And how many of you consider yourselves like security experts? No? Cool. So this talk's for you. So I am not a security expert, I'm just a developer. So I decided to name this talk Responsibilities. I think it had some other name on the schedule. I called it Responsibilities because it's our responsibility to make sure we deliver a good customer experience to the customer, right? Deliver a good product. And it's not like security's job to do security. It's not operations' job to do operations. We have to do this together. So if there's one takeaway to this talk, it's automation is a requirement. It's not a feature. So let's talk about the agenda. So this talk is basically a story about my team's journey into the public cloud and what we're doing to work with security and make that seamless. You don't have to do the things that I'm talking about in the talk, but it should inspire you to sort of do similar things to take control of your infrastructure. The talk is broken up into 3 parts. The first part is about how to get consistent and repeatable infrastructure with security controls built in. The second part is getting insight into your infrastructure. And the third part is sort of setting up guardrails because you would inevitably shoot yourself in the foot one day. So just protecting yourself. So as I said before, my name is Jearvon. I work at COMCAST, and I work on a team called XBO. We do all the back office stuff for the X1 platform. So if you have COMCAST and you're watching TV on any device, your device is probably talking to our systems. So we're a critical part of the platform, and we need to be secure and up at all times. So traditionally, this is where we run. Like it's a managed, not that specifically, but we run in a managed data center, right? So if you want to do anything, it's opening a ticket. You want a new node, you have to open a ticket, you need a firewall request, you have to open a Jira ticket, and these things could take like a day, half a day, or many days. So we wanted to get rid of this process and move faster and deliver features quicker and take more control over our systems and our infrastructure. So we decided to go to the public cloud, or AWS in this case, just to have on-demand resources that we could spin up and use at any time that we can do. So with a public cloud or any public space, it's easy to create resources, right? You can create a 128 node cluster, but you could also create an insecure 128 cluster open to the public internet. So how do you prevent yourself from doing that? One way would be security just restricting you from doing anything in your account, or you working together with them to have you do stuff. So a little bit of history. So earlier this year, we were like, yes, we're going to AWS. We're super excited. We get our account, and we can't do anything in it. So we can't create users, or we can't create security groups or anything. We're like, what's up? Like, how come we don't have the rights to do this? And the conversation went like, well, we don't really trust you, and we don't think you know what you're doing, so we're going to protect you from yourself. So we tried that way, even though we knew that that wasn't the way we wanted to go, but it was still painful. So the process was, if you want to create a service in AWS, you would have to think ahead of time of what ports, what IAM roles that you need to open, and then go to them, open a ticket, and wait a few days. And most likely, you'll probably have missed a port that you need open, and then you need to redo that whole thing, right? So we're like, we don't want to do that. Let's figure out a way that we can work together. So initially, this is what the organization looked like, and this is what we wanted it to look like. It's sort of there now. So the first thing we're going to do is do infrastructure as code. So what infrastructure as code does is automatically manage and provision resources through code. So if you want an EC2 instance or an RDS instance, you're not going through and clicking in the UI. You're basically writing some code to do that, and basically running that, and you're going to have your resources. So the tool that we chose for that is Terraform. How many people are familiar with Terraform? Cool, a good amount in the room. So I won't have to explain it. So the beauty of Terraform and why we chose it over something like CloudFormation is it interacts with more things than just AWS. So anything that has an HTTP API, you could write a Terraform provider for and interact with it. So the first thing that we get when we do infrastructure as code is visibility. So before, when we were doing stuff with, when we were separate, we would have to go ask, like, who's in this group, or what ports are open for this firewall, or just like, what is the IP range for this service or this zone? But now you can just go to GitHub, and you can view that stuff, right? You don't have to fiddle around in the AWS console or GCP console to figure out where this stuff might live. You go to GitHub, there's a well-named file, and you can see who's in the strange loop users group. Right now, there's Alex, and there's Jearvon, and I know what they do. Another thing is accountability. So with application code, we hold each other accountable doing code reviews and stuff like that. So why not do that with infrastructure of code? Yesterday in the Sentinel talk, Armand talked about remediation before, or guardrails before you get to production, and this is where that comes in. So basically, ahead of time, you could catch insecurities before they go to production. So one way to do this is code reviews. So here, there's a picture of someone adding a role to one of the code bases, and he clearly writes out like what's he doing and why this is useful and why we need this. So someone will then come in and either +1 or -1 it, and then it'll get applied, merged. Terraform will run it, and we would have this role. So you can envision doing some automatic checking against this also, like writing a pull request bot to +1 based on certain security group rules that you might want to enforce, or certain roles that you want to enforce. So it won't get merged, and you don't need a human to say it over and over again. So the other thing that you get is an audit trail. So we all use Git and for our application code, so your infrastructure code should also go in some type of version control. And for any compliance reason, if you need to know that who executed this change or who did this change, you have that automatically in Git. So here you can see like the Git log, and you can see that someone added 4 subnets to the EastProd VPC, or they renamed an instance profile. And then you could dig into that change and see exactly what it does. So another interesting thing with an audit trail is, let's say someone accidentally rolls out something that exposes S3 bucket. The change to revert that would just be reverting the commit and going back in time and just Terraform applying that again. So it's easy to make changes or just roll back your insecurities. Another thing you get is reusability. So before we were doing stuff in Terraform, security was doing things by hand. They would create each VPC by hand and each user by hand, and you're like, well, this thing doesn't have that, or that thing doesn't have this. So now they can create a module, or basically think of it as like a Java class or Ruby class that you could just reuse over and over and share, post it on GitHub, import it, and everyone has the same code that they can run off. In this example, we're using Terraform remote state. So let's say security has some valid security groups that they want you to use. You can reference those without that being in your code base. You basically store it in a remote place, and Terraform could look at it and read in that, and you don't have to do it yourself. So consistency is another thing that you get. So here, I'm creating another VPC, and what I did is I extracted all the rules that I think that an XBO VPC should look like. So it should have CloudTrail logs, it should have VPC logs, it should have certain users, and basically when I want to create a new VPC, I just reference this module, which again is just like a Java class, and I get all those things for free. If a change happens upstream that we want all VPCs to inherit from, we would change it in the module, bump the version, and have each VPC run that again. So basically, consistency across the board. So now when you want to create new VPCs or new accounts, it's not days-long processes. It's just a day max or a few hours. So now that we have infrastructure as code, we could do some automation, right? So one of the first things I mentioned earlier was, you can't have IAM access because we want to impose these rules on you. So what's a clever way to get around that? We have some code. We have some APIs that are exposed to us. So so this is a policy that AWS publishes. It's a force MFA on users, and there's some tricky stuff here where it just says, deny everyone that this is not true for. And the magic of IAM is if there's a deny anywhere in the chain, it'll just deny you. So we're denying any API access to anyone that doesn't have MFA turned on, which was something they were worried about. So when a user wants to get added to the account, let's say we hire Alex Miller tomorrow, and he joins the team, we want to add him to the account. Alex opens a pull request on the Terraform code. That gets code reviewed to make sure that he's getting added to the right groups and whatnot. And then Terraform plans it, Terraform applies it. Maybe it's just CI automatically doing that. And then we have this nice little shell script that basically sends Alex his password, and we don't have to have any interactions, basically. So all that's automatic. It's no longer a ticket. When Alex logs in, he doesn't have access to the console unless he turns on his MFA. So another thing is tests. So we have this infrastructure code. We can start testing it similar to how we test our application code, right? So some of the benefits of this is just ensuring that the assertions you're making are correct. So we use AWS Spec for this, and if you look through the Terraform module codes, you'll see examples of how people are using it. And it's basically just a Ruby gem that you include in your project. You can see here I'm just verifying that the group strange loop group has an MFA policy. And if it doesn't, it'll fail and tell me I could constantly run that in my CI environment or whenever a change is happening. So I'm not totally sold on doing a lot of tests for your infrastructure yet. Most of the testing I'm doing is just exploratory. So like, I'm working on something, I'm gonna write a test to verify that it's being done the way I want it to be instead of just going to the console or checking manually that that's being done. So that's a link for AWS Spec. You can go there later. So now that we have a repeatable, consistent infrastructure, we're gonna ship that to production, right? And then we're going to say, okay, let's spin up some VMs, let's make some accounts, let's make some roles and whatnot. We probably wanna see what those things are doing. So it would be nice to get insight into the system, getting some logs, getting some metrics, and some dashboards. So first up is logs. So for the VPC and for AWS, we store CloudTrail logs and VPC network logs, or VPC Flow logs, sometimes SSH logs and Bastion host logs. So anyone that's SSHing through the Bastion host, we log that and we could do some auditing on that. So you get another level of audit trails here. You can see who did what events happened, what they're doing, when they're doing. Let's say an instance gets terminated by someone by mistake. We can go audit that and say, okay, who did this and are there privileges? Do they have too much power here? Can we scale them back? So this is what so we pipe all the logs to Elasticsearch and we use Kibana because that's the easiest option. You could use Splunk or any other logging tool that would accept logging in JSON format. So this is just a Elasticsearch query. And then that's going to print out a table and say, so let's say I terminated an instance. Someone can go in and say, hey, who terminated this instance, what time, and the identity of that person. Another cool thing that was pretty helpful, and this is actually a positive case, is we're running in a hybrid network right now. So we have our traditional data centers and our public cloud. So traditional data center wants to connect to the public cloud. And sometimes we might not know ahead of time who to open up to. So AWS has this thing called VPC Flow logs, which just monitors all the network traffic coming into the VPC. So we set up some logs, and we could say, who's getting rejected, what's their source address, what's the destination they're trying to get to, and the port they're trying to get to. So then we can go evaluate that event, and whether it's a malicious or a friendly request, we can open up to them or keep denying them or investigate it some more. So we have all these logs. We could probably start collecting metrics on them. Similar to how we collect rejects earlier, we can start graphing all the rejects and API calls that are happening. So this is a Kibana dashboard that we have set up. So in the green, we're graphing all the active API calls that are happening in the VPC at any time by user or by role. And in the purple, we're showing rejects by network ID. So if you do this in the AWS console, it's super confusing. You have to click a bunch of things, and then you have to find the right network ID that you're using and jump through a bunch of hoops. But with Kibana, you basically could glue the data together very seamlessly. And then in the bottom here, we just have a table of recent events that are happening. So you could monitor events that are happening. If anything is looking funny, like if no terminate instances should be popping up an event name, you could alert someone. And then you see the username and the principal, so it's easily identifiable. Another dashboard that we have is using AWS Config, which is basically a rules engine for AWS. So this is a dashboard that we have set up for S3 buckets. And it shows S3 buckets that are not compliant with our rules. So for this rule, it's just whether the bucket is public or not. And this actually happened to us. So people accidentally opened up a few buckets, and no one had any idea until someone thought it was a good idea to check. So we set up an automatic check that will be evaluated every time the config on a S3 bucket changes. So the way config works is you set up a rule, and the rule checks a certain resource. And the rule could either be something pre-baked by AWS or a Lambda function that you can set up. And every time the configuration changes on that resource, it will run and check its compliance and then send you a notification or take some type of remediation step. So again, I mentioned we use Terraform, so we're not doing this stuff by hand. This is how you would set up a config rule with Terraform. It's basically super simple. This is straight from the docs. So we're saying, hey, the identifier is the S3 bucket, and the resource type is just the S3 bucket, again. So you can imagine, like, if this is something you want to run across all your accounts, you would stick that in your Terraform, like, base account module or base VPC module. And for every new thing that you bake or print out, you get this for free. And no one has to worry about, hey, is this a thing? Did we turn this on? Or something like that. So we have rules, we have logs, we have metrics. We could probably do some alerting. So with AWS, you could use CloudWatch alerts and set up some rules on what to alert on. If there's a bunch of unauthorized API requests coming in, you could send that to like Prometheus or CloudWatch and alert someone on your team that this is happening. So far we have alerting. So far we have insight into our system, and we have infrastructure as code, which gets us repeatable and consistent infrastructure. So now we're going to use that data that we get from the insight to sort of set up some guardrails for ourselves. So we're going to talk about remediation. So what this means is basically if something happens in your account and you get an alert for it, maybe you could automatically fix it or automatically change it back to the state it was in. Or if there's some type of drift happening, you could fix that drift. So our first example we're going to look at is CloudTrail logs, because that's super important for your account. If this is turned off, you can't get insight into what's happening into your system. So if someone wants to be malicious, they could get access to your account, turn off CloudTrail logs for like a minute, do whatever they need to do, turn it back on, and you never know that happened, right? So let's look at this. So we're going to use Terraform again. We're going to set up an event rule. And this is just a cloud event rule. And we're going to send it to a target. And the target here is a custom Lambda function. And this is what the Lambda function looks like. It's written. So you could write Lambda function. So Lambda is an AWS service that allows you to write serverless code. And you could use Clojure, which is a programming language that runs in a JVM, to write your Lambda code. And this is what a basic Lambda handle looks like. So when you want to do remediation, you probably have to do 3 things. Or you probably will do these 3 things. First, you'll fix it. You'll fix a problem. Then you'll log it for later, for looking at forensics or whatever you want to do with that data later. And then you're going to alert someone. And the Clojure code is super readable, right? So it's like, if you're not logging, if logging is not turned on, do these things. So the way this works is you set up a CloudWatch rule based on that event pattern and say you want to monitor this resource. And then when there's a change on that resource, it sends basically a JSON payload to your Lambda, which is an event. And in that event, there is a isLogging Boolean field. And that's what we're looking at. If it's not turned on, it'll be false. If it's turned on, it'll be true. So this stuff is basic programming, right? We do this every day. So we could basically do this for our security stuff also. So let's dig into the code a little bit. So this is our remediate function. We're basically just calling out to the AWS Java SDK and calling the method start logging if we see that logging needs to be turned on. We're going to give it the CloudTrail ARN. And our logging function for forensics is just saving stuff to DynamoDB. So we're going to say, hey, Dynamo, here's this CloudTrail table. This is the user that did it. This is the time they did it. If we see that they're doing it more than one time, so keep trying it again, we could lock them out or disable their account or whatever steps we want to take for that, right? So this is an example of what's happening. So you can see I have a shell script that basically checks the status of CloudTrail. And all it does is say, hey, is this true or not? So you can see at 5:53 and 16 seconds, it's true. CloudTrail is turned on. In the background, I call the command to stop CloudTrail, and you can see at 17:53:20, it's false. And then at 53:23, it's true again. So basically, it turns on within a few seconds. So you're going to lose some data, but it's going to be super fast to be turned on again. So you're going to constantly get data. And this is the notification we get. We just use SNS to send a notification saying, hey, someone is tampering with this. You should look at it. The next example is, let's say you have a tainted EC2 instance. And tainted could be relative to whatever you want it to be. In the example I'm using, if the EC2 instance gets a tainted tag. So again, you're going to do three basic things. You're going to fix a problem. You're going to log it and send an alert to someone. So for this example, all we're going to do for fixing this, so these rules are custom to your business logic, right? They're relative to however you want to handle the security vulnerabilities. So for this case, we're just going to set a security group that has no ingress or egress rules, so no one could SSH to it. Further out, you could also set like a non-modifiable policy, so no one can mess with the tags, or no one can delete it or terminate it. So let's say someone changes the tag to tainted, that sends an event to us, we get it, we've assigned a security group, and we basically quarantine the instance. And no one can get to it. We can go to it later and see what's up and look at it. Another tool we've been using is Cloud Custodian, which is a Capital One open source tool written in Python. And it's similar to Config, but it has a lot more capabilities, and it's free. So you basically write these policies in YAML format, and it can run in a Lambda, or you can run it every so often and get notifications, or it has different things that you can do, like turn off instances or shut them down within 4 days or something. So this one is just a policy that says, hey, we require these EC2 tags, and if they're absent and the state is running, notify someone about it. So someone on the team will get an email, and we'll go remediate that and fix it. You could also automate that and shut the instance off, stuff like that. So was this worth it? I think it was, even though it was super hard. So some of the things that we can do now, so we have full control over our accounts and our VPCs now, right? So we could use AWS in the way that it was intended to, so by taking advantage of security groups and IAM policies and being able to be super flexible and segmenting stuff out. We have a better relationship with the security team. Like, they can reuse some of the tools that we're writing, or if they need something, we can build it out for them. So what's next? There are some things that, so this is a work in progress. This migration will take maybe more than a year. We currently have some services in there. So AWS has a security benchmark white paper that they publish based on what they have seen in customers' accounts. And they wrote this Lambda that you could run against your account and basically see if your account is in compliance with like basic security things. So taking a look at that and having some way to run that maybe nightly or like once a week to see if our accounts are in compliance. Explore more of Cloud Custodian. So Cloud Custodian can do more than just tags or notifying. You can write some custom rules to do some cool stuff. Taking a look at SecurityMonkey, Aardvark, and RepoKit. So there are 3 Netflix security tools. Netflix takes this stuff seriously, and they take different angles on the security game. Taking a look at Sentinel. So there was a Strange Loop talk on Sentinel yesterday from HashiCorp, and that's a policy language, a compliance policy language. So you can set up rules on your infrastructure, and things won't get deployed if it fails the policy language. And then doing some chaos on our infrastructure. And what this just means is, like part of DevSecOps is like having the red team and stuff come in and break your stuff and try to break in. So maybe just automating some of that. So like a script that opens up an S3 bucket or opens up network traffic to an unknown resource and see how fast that could get remediated, and if we suffer any consequences from that. So some takeaways. Automation is a requirement, not a feature. As I said before, we're all responsible for this stuff, and we should not draw lines between our teams. We should work together. This stuff is super easy. If there's an API to something, you could probably automate it, right? So for anything that has an API, you can write a Terraform provider and have that stuff in GitHub instead of somebody manually doing that and just things running amok. You don't need to be in AWS to do stuff like this. You could do stuff like this in OpenStack or GCP. You just have to think about it a different way. Like instead of using Lambdas, you could probably use whatever GCP's serverless is. And whatever cloud you're in probably has an API that you can use and scrape logs from. So all this work to not create Jira tickets. So yeah, it was a long few months. That's pretty much the end of the talk. Say hi. I'm Jearvon on Twitter. That's my email if you want to email me about any of this stuff. We are hiring if you want to help me stop making Jira tickets and get rid of Jira at COMCAST. And I'm helping organize a conference on behalf of COMCAST that I could tweet the link to later. It's a free one-day conference in Philadelphia at the Barnes Foundation, which is an art museum. So if you want some tickets, let me know. And I could open up for questions now. Any questions? For me, it's more just verification that it's being done. So like, did I attach this correctly? If I didn't do that, I would have to go in and run the CLI to like simulate a policy or simulate something to do it. So it's just like a verification ahead of time. Some things I've thought about is like maybe trying to create users in the test, attach a group to them, and have that be like a nightly test that gets run or something like that.
You mentioned that closure was kind of pre-readable, and for a developer, true, but were everyone, you had to approve those? Were there developers who could really understand closure, or were there security people who maybe were not developers?
Oh no, so the Lambda stuff is just developers. Like we were just, like we will talk to them and say, hey, like this is something cool we're gonna do, and like they never know the implementation of it, they just know that it's being done.
So what were the security people using as a basis for approving or not approving what you
We would just have conversations and basically say like, this is, so like one of the things we did is like, all right, here's the IT compliance book for COMCAST. I read like many pages of it and just wrote those down in Terraform. So like password policies and who gets allowed access and stuff like that.
So it seems like the stuff you're doing with CloudWatch, verifying that nothing is not misconfigured, and the stuff that you do with AWS Aspect is sort of similar, but one is a test and one is like alerting. Is there a reason to use one or the other, or cases where one is better than the other?
So I don't have a good answer to that yet. I think you could think of AWS Spec as ahead of time, like when you're writing the code. And then CloudWatch is for when you're running the code. But as I said, I'm not making a lot of use of AWS Spec. It's just like,
So it's like throwaway to drive?
yeah, just like driving the implementation. And then when you go on, when you ship the Terraform code, you'll basically get an alert right away.
So I might be wrong. I think I read that Terraform has like a global state.
Mm-hmm.
Everybody needs to be using that global state to get the correct result. So if that's true, how do you manage that?
So that could get a little painful, but Terraform is very freeform, and you're allowed to layer your infrastructure however you want to, basically. So we've layered like account level stuff, VPC level stuff, and all that's stored in S3. And basically, you just set up a remote state when you want account level stuff, and you say, hey, this is where account stuff lives. This is the VPC I want to interact with. So we don't have everything in one global state. People might say that's bad or that's good, but it really depends on how, what feels good to you at the point in time. Any other questions? You could also use Terraform to deploy your Lambdas. Terraform all the way down. So, all right, if that's it, you can find me around to just ask some questions.